Hello everyone and welcome to this lecture on resource quota. Introduction to resource quotas in Kubernetes. Resource quotas are used to prevent one team from using more than its fair share of resources. These are defined by a resource quota object in Kubernetes. It sets constraints that limit the total resource consumption per namespace. So just this thing to remember that it's basically we have put resource constraints for a particular namespace, and that namespace can be assigned to a team or a department, and that's how within a Kubernetes cluster we allocate resources based on namespace, and that helps in distributing it to teams. This includes the limitation of the number of objects that can be created in a namespace as well as the total compute resources that can be used. So how resource quotas work? Different teams work in different namespaces which can be enforced with role-based access control. The administrator creates one resource quota for each namespace. Users create resources such as pods, services, etc. in the namespace. The quota system tracks usage to ensure it does not exceed hard resource limits defined in a resource quota. So resource quota constraints and violations. If a resource quota constraint is violated, the request will fail with HTTP status code 403 forbidden and along with the message. The message will explain the violated constraints. If quota is enabled for a compute resource, if quota is enabled for compute resources like CPU and memory, users must specify request or limits for those values. For CPU and memory resources, resource quotas enforce that every new pod in the namespace sets a limit for those resources. Enabling resource quotas. So resource quota support comes as a default feature in many Kubernetes distributions. So by default it's there most of the time, but this is just something to be aware of. It gets activated when the API server has resource quota listed as one of its arguments. A resource quota is strictly enforced in any particular namespace only when there is a resource quota object in that namespace. So this is an example of compute resource quota. So we have resource name and some description. So first is limits.cpu across all pods in a non-terminal state, means they should not be terminated, non-terminated state. The sum of CPU limits cannot exceed this value. Limits.memory across all pods in non-terminal state, the sum of memory limits cannot exceed this value. Request.cpu across all pods in a non-terminal state, the sum of CPU request cannot exceed this value. And request.memory across all pods in non-terminal state, the sum of memory request cannot exceed this value. And we have huge pages dash size across all pods in non-terminal state, the number of huge page requests of the specified size cannot exceed this value. And CPU and memory, so this is limits.cpu and limits.memory. This CPU and memory, if it's defined like this, it's same as request.cpu. So just remember, CPU and memory is same as request.cpu and memory. Okay, storage resource quotas. You can limit the total sum of storage resources that can be requested in a given namespace. Additionally, you can limit consumption of storage resources based on the associated storage class. Various storage resource types are supported, including request.storage, persistent volume claims, and specific storage class related quotas. So storage resource quotas, some examples, we have request.storage across all persistent volume claims. The sum of storage request cannot exceed this value. Persistent volume claims, the total number of persistent volume claims that can exist in the namespace. Then we have storage class name dot storage class dot storage dot k8s.io / request.storage across all persistent volume claims associated with storage class name. the sum of storage requests cannot exceed this value, and we have storage class name dot storage class dot storage dot k8s.io / persistent volume claims. Across all persistent volume claims associated with storage class name, and the total number of persistent volumes claims that can exist in the namespace. So this is total number of persistent volume claim, and this is sum of storage class across single within one storage class name. And these two are just storage across the cluster and persistent volume claims, the total number, but within one namespace. So object count quotas. Object count quotas are useful to limit the total number of certain resources of all standard namespaced resource types. Syntax like count / resource dot group for non-core groups and count / resource for core group resources is used to set count quotas. These quotas are useful to protect against exhaustion of storage resources, such as limiting the number of secrets in a server given their large size. So these are the object count. So how many count of certain object can be created? So we have config maps, the total number of config maps that can exist in the namespace. Persistent volume claims, the total number of persistent volume claims that can exist in a namespace. Then we have pods, the total number of pods in non-terminal state that can exist in the namespace. A pod is in a terminal state if status.phase in failed.succeeded is true. So these two is called as terminal state if these two values exist, failed and succeeded. Okay. Replication controllers, the total number of replication controllers that can exist in the namespace. So this, just think of deployments, replica sets, stateful sets, daemon sets. Resource quotas, the total number of resource quotas that can exist in the namespace. And services, the total number of services that can exist in the namespace. Services.load balancers, the total number of service of type load balancers that can exist in the namespace. Service.node ports, the total number of service of type, this particular type, node port, that can exist in the namespace. And then we have secrets, the total number of secrets that can exist in the namespace. Okay. Resource quotas for pod count. Pods quota counts and enforces a maximum on the number of pods created in a single namespace that are not terminal. Importantly, neither contention nor changes to quota will affect already created resources. You might want to set a pods quota on a namespace to avoid a scenario where a user creates many small pods and exhausts the cluster supply of pod IPs. So that's why this is important. Like you can create very high number of pod, and that will, every pod will get its own IP, and that can completely exhaust the total supply of pod IPs. So that's why you want to prevent it. So you don't want a single team to completely like exhaust all the cluster IPs. So understanding quota scopes. Quotas can have an associated set of scopes. A quota will only measure usage for a resource if it matches the intersection of enumerated scopes. Some of the notable scopes include, some of them are terminating, number 1, not terminating, 2, best effort, not best effort, priority class, and cross namespace pod affinity, each having a specific function. A scope, when added to the quota, limits the number of resources it supports. We cannot specify both the terminating and not terminating scopes in the same quota, and likewise for the best effort and not best effort scopes. So these are some quota scopes. We have terminating, not terminating, best effort, not best effort, and priority class, and it matches some specification within the pod, like .spec.active deadline seconds greater than or equal to 0. Not terminating match pods where .spec.active deadline seconds is nil. Best effort, match pods that have the best effort quality of service. Not best effort, matches pod that do not have best effort quality of services. And priority class, match pods that reference the specified priority class. Okay, scope restriction and resources TRAD. The best effort scope restricts a quota to tracking only pods. The terminating, not best effort, and priority class scopes restrict a quota to tracking resources including pods, CPU, memory, request.cpu, request.memory, limits.cpu, and limits.memory. Constraints such as not being able to specify both the terminating and not terminating scopes in the same quota apply. So resource quota per priority class. A pod's consumption of system resources can be controlled based on its priority using the scope selector field in the quota spec. When quota is scoped for priority class using scope selector field, quota object tracks resources including pods, CPU, memory, ephemeral storage, limits.cpu, limits.memory, limits.ephemeral storage, request.cpu, request.memory, and request.ephemeral storage. Pods in the cluster can have one of the three priority classes: low, medium, high. One quota object is created for each priority. So this is one example of resource quota and priority class. So this one is having name pods high, and it has got some spec like hard CPU value, 1000 memory, pods, how many pods, scope selector. So this is a high pods, means high number of pods you can create, and with this kind of resources. So this is total overall within a namespace, like you have 200 gigabyte and 10 pods and 1000 CPU. These are values are very high, and this is a scope selector field. Match expression priority class in high. So this the way you read is priority class in high. So pods which has got this priority class. So I'll show you via pod how this get assigned. So in this example, this is a list. So we are creating three priority classes. Three resource quota: pods high, pods medium, and pods low. So these have low number of pods and low memory and CPU. This one has medium and this one has high. So these, once we create this, if you do kubectl describe quota, you will see these values. So we have pods high and with those values, then pods low and pods medium, and we have assigned a priority class also. Now within a pod, how you will define it? There is a pod name, containers, all these things are as normal as usual, and that has got resources like 10 gigabyte, 500 millicore request and memory. And herein within, you see this one is coming under spec section. So this is priority class name high. So this priority class name is within spec of pod, not inside the container. So this can actually go here also. So this one goes to the high resource quota. So if you just do kubectl describe quota, after you create the pod, you will see that some of this is occupied. So pods 1 out of 10. So before, if I show you, it was you will see, observe here, 0 out of 10, and after creating this pod, this is 1 out of 10. Okay, cross namespace pod affinity quota. The cross namespace pod affinity quota scope can limit which namespaces are allowed to have pods with affinity terms that cross namespaces. It controls which pods are allowed to set namespaces or namespace selector fields in pod affinity terms. Operators can prevent certain namespaces from having pods that use cross namespaced pod affinity by creating a resource quota object in that namespace with cross namespace affinity scope and a hard limit of 0. If operators want to disallow using namespaces and namespace selector by default and only allow it for specific namespace, they could configure cross namespace affinity as limited resource. So this one is example of cross namespace, like disable cross namespace affinity. This is of type resource quota, and it has got some hard limit, match expression, scope selector, cross namespace affinity, and then you have some admission configuration. So this is a bit advanced topic, but I'm just covering it just in case you come into some production or real world scenarios where you have to suggest some solution based on that. So it's good to be aware of or just remember a bit of this information. So there is something called as admission configuration, and there's a plugins resource quota, and then you use the one which we have created, scope name, and this is used for okay. So I'll just try to so here in the cross namespace pod affinity quota scope, to limit which namespaces are allowed to have pods with affinity terms that cross namespaces. Specifically, it controls which pods are allowed to set namespaces or namespace selector fields in pod affinity terms. Preventing users from using cross namespace affinity terms might be desired, since a pod with anti-affinity constraints can block pods from all other namespaces from getting scheduled in a failure domain. Using this scope, operators can prevent certain namespaces, for example foo.-ns in the example below or example above, from having pods that use cross namespace pod affinity by creating a resource quota object in that namespace with cross namespace affinity scope and hard limit of 0. So if operators want to disallow using namespaces and namespace selector by default and only allow it for specific namespaces, they could configure cross namespace affinity as a limited resource by setting the Kube API server flag. There is a flag admission control config file to the path of the following this configuration file, and with the above configuration, pods use namespaces and namespace selectors in pod affinity only if the namespace where they are created have a resource quota object with cross namespace affinity scope and a hard limit greater than or equal to the number of pods using those fields. Okay, so resource request and limits in Kubernetes. So this is related to request and limits. So when allocating compute resources in Kubernetes, each container can specify request and limit values for CPU and memory, so which we have seen. So there is like a CPU and memory, and both have requested CPU and CPU limit and CPU request. Same for memory request and memory limits. The quota system can be set up to monitor and enforce either the request values or the limit values. So the quota is basically used for this purpose only, to monitor and basically to enforce, mostly to enforce these values, request limits or the limit values, request values and the limit values, sorry. Okay, if a quota has values specified for request.cpu, so this is important. If a request has values specified for 1 request.cpu or request.memory, it will require that all incoming containers make explicit request for those resources. So if request is set either CPU or memory, it will make sure that all incoming containers make explicit request for these resources. Similarly, if the quota has values for limits or .cpu or limits.memory, it will require that all incoming containers explicitly specify their limits for those resources. So viewing and setting quotas with kubectl. So kubectl we can describe. So kubectl supports creating, updating and viewing quotas. So namespace creation and specific resource allocation commands. So I'll show you in the next example. And quotas are viewed using kubectl get quota and kubectl describe quota commands. So object count quota and clusters capacity. kubectl also supports object count quota for all standard namespace resources using specific syntax. Resource quotas in Kubernetes are absolute units and independent of the actual cluster capacity. Adding nodes to your cluster does not automatically allow each namespace to consume more resources. Advanced policies such as proportional resource division, flexible usage growth, demand-based quota adjustments can be implemented using resource quotas as a base and by writing a controller to monitor quota usage and adjust limits as needed. Okay, limiting priority class consumption. Kubernetes allows operators to limit the consumption of certain pod priority classes within specific namespaces, creating a match between the quota object and the priority class. This mechanism helps to ensure that not every namespace can consume high priority classes by default. So you can have something called priority class consumption, and you set limits, and so that all pods cannot, so operators can limit usage of high priority classes to only specific namespace. So high priority namespaces can use priority class, but not all other namespaces. And pod creation will be permitted if the pod's priority class name and quota check matches. So there is a compliance between these two values, and that's all. So some of the concept actually like priority class consumption and others we're a bit advanced, but it's good to know that these features do exist, and in certain scenarios we may use those, but to summarize it, basically resource quota is for a namespace just to make sure the teams don't overcross or consume all the resources. And most basic things that we usually do is like set the minimum for the request.cpu, request.memory, and limit.cpu and limit.memory. So if you just remember this, that will be good enough. But there are some advanced features that if you are aware, that's good to know actually. And with that, thanks for watching.